All right, today's lesson is going to be, well, if you understood yesterday's and paid attention while we were going over problems today in class in this lesson that you'll be doing over the weekend or hopefully maybe even today when you get done with school, uh, it shouldn't be too bad for you. It's the same idea, we're just solving these linear equations. It's called part 2 here though because the equations are a little bit longer. Okay, so things you want to always do is you always want to identify, first of all, what kind of an equation you have. And since we're doing linear equations, every x should just be to the first power. Again, they don't show the ones for an exponent. Otherwise, we'd be writing ones every time we just wrote down a variable. And then after you do that, identify where your equal sign is, so you can identify a left side and a right side. So draw that dotted line right here to separate it. And step 1, if you recall from yesterday, is simplify each side. So let's identify what we've got on the left-hand side here in terms of like terms. 3x and 2x are like terms. They're on the same side of the equal sign, both on the left. So we can just combine those two. I've got 3x's on this side. I've also got 2x's on this side. So the left-hand side simply becomes 5x's minus 6 and my equal sign. And the right-hand side has no like terms. There's a constant term, no variable with it. It's an x term. Those cannot be combined, so we'll just carry them down. So that's step 1. Okay, combine or simplify each side of the equation. Next step, get all your variables on the same side. I mentioned it yesterday. I generally try to get all my variables on the left. So that means this 9x, which is on the right-hand side, has to get moved over to the left-hand side. Well, you do that by getting rid of it on the right. And you get rid of it? Well, it's added to the right, so I subtract it from the right. And I subtract it from the left then to keep the equation nice and balanced. And now we just do one step at a time here. 5 take away 9 is negative 4. My minus 6 just carries down. The 18 just comes down, but these two cancel, so my x is no longer on the right. Next, I move anything that doesn't have a variable with it to the right-hand side. So if I look at the left-hand side, I've got this minus 6. So I just do the opposite. I'm going to add 6. And I'll add 6 to the right-hand side as well to keep us balanced. And you just do the math here, negative 4x, nothing's being done to it. These cancel out. 18 plus 6 is 14. And then our final step, all we have to do is undo any multiplication or division to get x alone. Here it is negative 4 times x. So I do the opposite of multiplication. I use divide by negative 4. And negative 4 divided by negative 4 is just 1x, or just x. And the other side I can just write as 14 over negative 4. But that simplifies to 7 over negative 2. And in general, we put that negative sign in the numerator. But either of these would be equally correct. But reduce your fraction to lowest terms. So x is equal to negative 7 or 2, or if you want to, negative 3.5 as a decimal. Okay, so the problems are a little bit longer, but it's just the same steps, just more of them. Next example, boy, this looks tough because we've got this decimal value and this decimal value here. Okay, we can see we've got x's to the first power. Here's our equal sign right there. So let's work on the left-hand side first, and we will distribute. Get rid of these parentheses. So we get 4.2 times x, which you write 4.2x, plus, now you can get out a calculator if you need to, because you have to take 4.2 times 5. I believe that is 21. There's our left-hand side. Right-hand side will distribute there as well. 2.5 times x, and 2.5 times 2, which is 5. Okay, we got x on the left here, 4.2 of them, 2.5 on the right. So let's move our x's to the left. We'll do the opposite, subtract 2.5 x's. See, those just cancel each other out. Don't forget, you got to do the same thing to the other side. And I believe that is 17, or 1.7x plus 21 equals 5. We remove any numbers from the left-hand side, anything that doesn't have an x, so we'll subtract that 21 both sides. 1.7x equals 5 minus 21, negative 16. And lastly, we'll undo that 1.7 times x with divide by 1.7. Divide by 1.7. 1.7 over 1.7 is just 1x equals, and this negative 16 over 1.7 is a terrible answer just because that is a fraction mixed with a decimal. So I'm going to take and do something kind of clever. You could just get out your calculator here and type that in and get a big decimal for it. I'm going to leave it as a fraction. I'm going to multiply just this right side by 10 over 10. 10 over 10 is still equal to a 1, but it changes the way this number looks. 16 times 10 is 160, and 1.7 times 10 is 17. 17 does not go into 160 evenly, so now I can just leave it as a fraction. 17 is prime. This fraction will not reduce. And so that's an okay answer. If you did go ahead and type that into a calculator and got a decimal, that would be fine as well. But we're done. Okay, here we've changed our variable up. We're using a's instead of x's, and I should have used a's all the way through, so I'm going to get rid of that 5x and rewrite that with a 5a. Just so you can see it doesn't matter what your variable is. So let's clean up the left-hand side. Here is our equal sign. We've got a, and it's minus 2 times all that stuff. So we're going to distribute that negative 2. And we're going to get as follows. So we've got our a. Here we go. Negative 2 times a. Negative 2a. Negative 2 times a positive half is, negative 2 times a half is negative 1. Equals 5a plus 1. Now we're not done simplifying the left-hand side yet. We got a, take away 2a. So it's 1a minus 2a. That's negative 1a. And you can put just negative a or negative 1a. Now, just to mix things up a little bit, we got to get our a's all together. I could subtract the 5a and move my a's then over to the left, but instead this time I'm going to move my a's to the right. So I'm going to add positive a, 1a to this side. Those will cancel each other out. I'm going to add that a over to the right side. So I get negative 1 equals 6a plus 1. All my a's are now together on the right, so I'm going to move any terms that don't have a away from it. So I'm going to subtract this 1 away from that a side. Negative 1 take away 1 is negative 2 equals 6a. So all my a terms are on the right. Everything without an a is on the left. I've got to get a by itself now by dividing by 6. It's 6 times a, so I'm going to do the opposite of multiplication, which is division. 6 over 6 is 1, so I get a equals negative 2 over 6. I'm going to rotate that around, putting the a on the left, and I'm going to reduce my fraction. So a is negative 1/3. And here's our last example. Again, these are tougher problems. Okay, here's an x over 3, an x over 4, an x over 5, okay, equals 2. So on the left-hand side, we actually have 3 x terms. This is 1/3 of an x plus 1/4 of an x plus 1/5 of an x. Now these are just fractions, so we can add them all together. But to add fractions, you have to have a common denominator. If you remember about getting common denominators, you look at the multiples of the denominators. Okay, multiples of 3 are 1 times 3, 3, 2 times 3, 6, 3 times 3, 9, and so on. And just keep counting by threes. Okay, then you have to do the same thing with 4s. 4, 8, 12, 16, 20, 24. And you have to do the same thing with 5s. 5, 10, 15, 20, 25, 30. Holy cow. And so what we're looking for here is the first number that they all have in common. Okay. Now I could carry this out until they all match, but let's just think about it for a second here. We got to find a common multiple for 3, 4, and 5. And 5's always going to be just 5's and zeros that it ends in. 5, then it ends in a 0, then a 5, then it ends in a 0. 3's, let's see here, 3 times 5 is 15. 3 times, I'm trying to think of other things that give me a 0. 3 times 10 is 30. Let's see if 4 times anything gives me 30. No, it doesn't. I think we're going to have to go all the way up to 60 before we get a common multiple. That's pretty big. That's all right. So I'm going to just take this first fraction times 20 over 20, because that gives me 20 x's over 60, which is still 1/3. I'm going to take x over 4 times a 15 over 15. That gives me 15x over 60. And lastly, I'm going to take x over 5 times 6 over 6. Nope. Times 12 over 12. Because that gives me 12x over 60 equals 2. Now that they all have common denominators, I can just add all these numerators together, and my answer will be over 60. It's 20, 35, 47x equals 2. And that was a ton of work. Now, if you have just a nice calculator that does fractions, you can actually accomplish this just by typing in the fraction 1/3, that's our x over 3, plus 1/4, that's our x over 4, plus our 1/5, that's our x over 5, and it will give you 47 over 60. Okay, last step now. See, we've got all our x's already on the left-hand side, and we just have a number without an x, a constant, on the right. So our last step is to get this x alone. It's a little bit tougher because we have this really messy fraction on the left-hand side. But here's another little math trick. I can multiply this side by the reciprocal of that fraction, and I can multiply the other side by that reciprocal as well. Now on the left-hand side, what happens is this 60 will cancel the 60 in the denominator, and this 47 down here will cancel that 47, leaving us with just an x equal to, and when you multiply fractions, just multiply the numerator times the numerator. 2 times 60 is 120 all over 47. So while it's not a very pretty answer, that is what we get. Now again, if you have a calculator nearby, you can do this, much quicker, but you still need to show these steps. So for example, if you did this math in your calculator and you got 47 over 60, your next step, it would go from this in the black, the original problem, straight to this in the red, and you could skip this green line. Okay? Then you can show this last step, and your calculator can do that math as well. All right, that's it. Good luck on the lesson. All the problems I did here in these examples are very similar to your homework problems.